This is the video for your notes on SOL 6.15, or balance point and measures of center. It covers pages 97 through 98 in your notebook, and you'll need one pencil to complete these notes. You would use this measurement to find the middle point. That's really important. The middle point with a set of data that does not have any really high or really low numbers compared to the rest of the data. And the really high, really low, that means that's a different way of saying outliers. So I want to find the number that's in the middle. So if I take all of those numbers and add them together, I'll get a sum of 72. So I add all of these up together and I get 72. And that will be our numerator, or the number that's being divided. And we're going to divide that into 8 even groups because there are 8 numbers. And we see that there are 8. So 8 is the number of numbers that we have. And that's what we are going to divide the 72 by. And that's going to be in our denominator because fraction means division. So 72 divided by 8 is 9, and 9 is the mean of this data. Another way to say mean is balance point. So you want to use these synonymously. They mean the same thing. You would use this measurement to find the middle point with a set of data that does have some really high or really low numbers compared to the rest of the data. So we want the middle point, but these really high or really low numbers would be outliers. So 6 would be the median of this data set because the 2 and the 9 kind of match up as the biggest and smallest of the numbers. Then the 4 and the 8 match up, then the 5 and the 7 match up, and 6 is in the middle. So this is called the median. Now that wouldn't be the best set of data to find the median as the middle point. So if I had a really high number on this side, such as 72, or a really low number on the other side, like negative 42, then those would let me know that the median would be the best measurement for that set of data. When you would use this next one when looking for identical values. It shows the number that repeats the most often. And this is really good for yes or no surveys, or to see what the most popular choice was. So the one that's the most often is the mode. They sound very similar, and that's how I remember. Out of your 6th grade math class, I want to find the middle height. So in a 6th grade math class, there's no one that's really, really tall normally, or really, really short. Everyone's kind of within a decent range of each other. So it's probably best to use the mean. But if you look at the 6th grade math class, and there's a 7-foot person that walks into our classroom, and I want to find the middle height of everyone that's in the room, then this 7-foot person would be way, way, way taller than everybody else in our classroom. So this would be our outlier. That height is out and far away from the rest of the heights in the classroom. So the median would be a better representation so the 7-foot person doesn't kind of skew the data to one side. So if I took a survey of Sterling Middle School to see who likes gum and who does not like gum, and I want to know what the most often response, what response we got the most often, I would use the mode. If I want to find the middle of this data set, I see 56 over here is way bigger than all of the other numbers, so this is an outlier. And if there's an outlier in your data set, then the median would be the best measurement. If I want to find the middle of this last set of data, all of the numbers are relatively close to each other. So there's no outliers, no really, really small or really, really big ones in comparison to the other numbers, and this would be. If I want to know where the balance point for this set of data is, I am going to try to keep moving them to the center to see where all of those x's would balance on the number line. But the balance point is the same thing as the mean. So I see that there's 2 x's on 1. So I have 2 1s, and then I have an x on 2, on 4, 3 on 5. So I'm going to write 3 5s. I have 1 on 6 and 1 on 7. So if I find the mean of all of these numbers, I'm going to add them all together, and I right away see that 5 plus 5 plus 5 is 15, 4, 5, 6, 7, 8, 1 plus 1 plus 2 plus 4 adds up to be 8, and 6 plus 7 adds up to be 13. So I'm going to add those on the side and see that 15 plus 13 plus 8, so 5 plus 3 is 8, and 8 plus 8 is 16. So I put 6 down in the ones column and carry the 1, and 1 plus 1 plus 1 is 3. So I see that the sum of that data is 36. But I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 of those numbers. So I'm going to divide the sum into 9 even groups, and I get 4. So I know ahead of time that it's probably going to balance on the 4. So I'm going to try to see how many times I could jump it to the right and how many times I could jump it to the left. Because when I move a number from 7 to 6, I just took away or subtracted 1 from that sum. And I subtracted another 1, so I just subtracted 2. When I move everything to the right, I'm adding 1. So 1 plus 1 is 2. 1 plus 1 is 2. So I just added 2, but then I subtracted 2. So that balances out. I'm allowed to do that. So I moved 2 to the right, or added 2, and then I moved 2 to the left. So we want to make sure that these movements balance out, because adding 2 and then subtracting 2 is the same as adding 0. So I'm going to add 1 more. So I'm going to add 1, 2, 3 more. 1, 2, 3 more, and kind of record that, keep track of it. Then I am going to subtract 1 from the 6 to make it 5. And I'm going to record that I subtracted that. And we see that a lot are balancing on 3 and 5 right now. So I'm going to subtract 1, 2 more and record that. So now I'm even, but I still have some that are left on 5. So I'm going to take these 3, and I'm going to subtract 1 to make it 4. So I'm going to subtract 1, 2, 3, and I'm going to record that I subtracted 3 more. But now I need to add 3 more from the other side. So I'm going to add 1, 2, 3. And we see that all of those x's are now balanced on 4. That's why we call mean the balance point. So I moved 1, 2, 3, 4, 5, 6, 7, 8 to the right. So I added 8, and then I subtracted 1, 2, 3, 4, 5, 6, 7, 8. So I added 8 and subtracted 8, and I got all of those to balance on the 4. So that's the mean and the balance point. What is the mean for this set of data? Now, I started finding out the mean with the math rather than looking at the chart. This time, I'm going to start with the chart. So I'm going to add 1, 2, 3, move all the ones from the left-hand side in as much as I can, and then move 1, 2, moving all of the ones on the 6. So I kind of moved subtracted 1, 2, 3 because I moved 3 to the left. So I'm trying to make sure that they're all balanced out. So I take all of the ones that are on 2 and I can add 1. So I can add 1, 2, 3, 4 to get all of those 2's on the 3. So I'm going to keep track of those 4 that I added. Now I'm going to subtract 4 to balance it out. So I subtracted 2, 3, 4, And now I know that I've added the same amount that I've subtracted. So I added 7 and then I've subtracted 7, and they all line up or balance on the 3. So the 3 is my balance point, which is the same thing as my mean. I have 3 x's on the 1s. I have 1x on the 2. I have 2 3s. I have a 4. And I have 2 6s. So if I go back and try to show this with the math, I can add everything together and divide by the total number of data points that I see. So 4 plus 6 plus another 6 is 16. I have that all of these together. 3 plus 3 is 6, 7, 8, 9, 10, 11. And 16 plus 11 ends up being 27. So 27 is my sum, and dividing that by the 1, 2, 3, 4, 5, 6, 7, 8, 9 total data points, I see that 27 divided by 9 ends up being 3. So I ended up in my picture having 9 3s, then my balance point or my mean is 3. which number line represents a set of data whose balance point is 5? So I want to know if everything that I add to get to 5 and everything that I subtract to get to 5 balances out. So I added 4, and I'm going to subtract to get to 5, and now I'm going to subtract 1, 2, 3, 4, 5, 6, 7, 8, 9 to get to 5, and adding 4 and subtracting 9 does not balance out. So A is not the correct answer. Now for B, I want to get it to 5, so I'm going to subtract 2, and then I'm going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I see that adding 10 and subtracting 2 does not balance out on 5. So for C, I'm going to add 1, 2, 3, 4, 5. And on the right side, I'm going to subtract 1, 2, 3, 4, 5. So that seems to balance out on 5. Let's try D to double check. I'm going to add 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I added 14 to get everything on the left side to 5. And I'm going to subtract 1, 2, 3, and then I should have subtracted a few more, 4, 5, 6, 7, but subtracting 7 and adding 14 doesn't balance out, so C is correct. For number 6, I want the balance point to be at D. So I want the balance point to be at D, and I'm going to add 1, 2, 3, 4, 5, 6, 7, 8. So I added 8 to everything on the left side to get it to D, and I'm going to subtract 1, 2, 3, 4, 5, 6. So I am subtracting 6 on all of the ones on the right side to get to letter D on the number line. And for C, I'm adding 1 to get to D. And for B, I'm adding 2 to get to D. And if I'm on A, I would have to add 3 to get to D. E, I would subtract 1. From F to D, I would subtract 2. And from G to D, I would subtract 3. And from H to D, I would subtract 4. So I could have put numbers on all of these and just found which one gives me the correct mean, but this is another method of finding out the answer. So for answer choice A, point B and point G would need plus 2 and then minus 3. So 8 and 2 make 10. 6 and 3 make 9, and adding 10 and subtracting 9 doesn't balance out. For answer choice B, we want to see if putting 1 on C and putting 1 on G makes sense. So C, I would need to add 1, and G, I'd have to subtract 3. So 8 and 1 make 9 that I'm adding, and 3 and 6 make 9 that I'm subtracting. So that seems like the best answer choice so far. For point B and point F, I would need to add 2 and then subtract 2. But 8 and 2 make 10, and 6 and 2 make 8, so that doesn't balance out. I'm adding more than I'm subtracting. So for C, I have 8 and 1 is 9, 6 and 2 is 8, so adding 9 and subtracting 8 doesn't make sense. And B, answer choice B, is the correct answer. Which line plot shows a set of numbers with a balance point of 23? So I want them all to balance on 23. So I'm going to add 1, 2, 3, 4, 5, 6. So if I add 6 to get them to 23, and I have to subtract 1, 2, 3, 4, 5, 6, then it seems like 23 is the balance point of this set of data. Let's double check the rest. I would need to add 1, subtract 1, 2, 3, 4, 5, 6, and we see that it does not balance out on 23. I would need to add 1, and I'd need to subtract 1, 2, 3, 4, 5, 6 to move everything to 23, and we see that that does not balance out on 23. I'd need to add 1, 2, 3, 4, 5, 6, 7, 8 to move everything to 23 on that side, and I'd have to subtract 1, 2, 3, 4 to move it to 23, and we see that adding 8 and subtracting 4 does not balance out, and A is your best answer.